Hi everybody, today we're going to be finishing up our chapter on periodic trends. I know it's a short one. Last class we talked about the atomic radius and the ionic radius and what those trends looked like on a periodic table. Today we're going to be talking about two new terms. We're going to be looking at ionization energy as well as electronegativity. Let's get started. So let's start by defining ionization energy. Ionization energy is simply put the energy required or the energy that we need in order to remove an electron from a specific atom. We might want to do this in order to form an ion or for some other reason, but we do need to input energy in order to do this act. For any given atom, it's going to be easier to remove those outermost valence electrons first. However, as we get closer to the nucleus in those inner electrons, those are going to be harder to remove because they're closer to the nucleus and they have a stronger pull or force of attraction to the center, to those protons. Therefore, ionization energy is going to increase with every single subsequent electron that you remove. In general, you're going to see that ionization is going to increase as we're going from left to right across a period, and it's also going to increase as we go from the bottom of a group to the top of the group. Let's focus on a single period or a single row. As you're going from left to right across a period, we saw that we are going to be adding more protons. As the number of protons increases, remember that means our force of attraction is also going to increase. The stronger the force of attraction between the nucleus and its valence electron, the harder it is going to be to remove those electrons, to pull it away. Thus, more energy is going to be needed. So your nonmetals are going to be the ones closer to the right side of your periodic table, and these are going to be pretty close to our noble gases, right? They would become stable by gaining electrons so that it can have that same configuration as a noble gas. Therefore, if we're talking about removing electrons, that's not going to be a favorable act. That's why it's going to require way more energy to remove those electrons. So then you'll see ionization as you're going from left to right across the period increases. Now let's look at ionization energy within a group or a column. So notice that your elements near the bottom of the periodic table, those are going to be ones that are in higher energy levels, and therefore their valence electrons are going to be located further away from the nucleus. If your valence electrons are located further away from the nucleus, then they're going to have a lower force of attraction. Remember, as distance increases, your force of attraction is going to decrease. If that force of attraction isn't very strong, then those electrons are going to be easier to remove, requiring a lower ionization energy. However, as you are going up a group, that atomic radius is going to decrease in size. That means my force of attraction between the valence electrons and the nucleus is going to increase, and thus it's going to require more energy for us to try to remove or pull an electron away. Therefore, as we're going from the bottom of the group to the top of the group, you'll see that ionization energy increases. Moving on to our final trend, we're going to be looking at electronegativity. And a lot of people get this definition and ionization energy mixed up, but they are different. Electronegativity is going to be a measure of the ability for an atom to attract electrons. Basically, how badly does an element want to gain and attract more electrons? Overall, you're going to see a similar trend. Electronegativity generally increases going from left to right across a period, and again, it's going to increase going from bottom to top within a group. In a single period, we know that our metals are mostly located on the left side of the periodic table, for example, like in group 1 or group 2. Since metals have fewer valence electrons, they tend to become more stable by losing electrons. Notice that the noble gases that they are closest to, it is easier for them to lose electrons in order to look like that stable noble gas. Therefore, our metals tend to form cations. Nonmetals, on the other hand, are going to be closer to the right side of the periodic table. These tend to have more valence electrons. For example, elements in group 17 have 7 valence electrons. So therefore, they tend to become more stable by gaining electrons because they are really close to a noble gas already, and so that by gaining electrons, it can look like that noble gas. Therefore, our nonmetals tend to form anions. That means that our nonmetals really want to gain electrons. They are really more attractive to electrons versus our metals on that left-hand side, they would much rather lose an electron, so it's not going to be as attracted to an electron. Therefore, we will see electronegativity increase as we're going from left to right across a period. Electronegativity is generally also going to increase going from bottom to top within a group due to its smaller atomic size. Now notice that the most electronegative element is going to be fluorine. It is not going to be helium or any of the noble gases. Notice that your noble gases, they are not electronegative at all because they are already stable. They do not want to gain or attract any more electrons. Therefore, when we're talking about electronegativity, we're really only focusing on elements within group 1 to 17, not our noble gases. Okay, that's it. So just a quick review. Our ionization energy and our electronegativity, we're going to see that is going to increase both as we go up from bottom to top in a group, as well as when we are going from left to right across the periodic table. Thank you guys. See you guys next time. Bye.